Who cares? Speed up the process of this whole thing. This isn't going away. Alright, now it is. Well, you can use that to help you out, children. How, you ask? Well, if you see a problem like this, anybody know the answer to this? 1200 divided by 16. Somebody do that in their head? Yeah, probably not. Well, based on what we're doing over here, what I can do is, I can, as long as I divide both of these or multiply both of these by the same number, I can make really the same problem that's going to give you the same answer. So the first thing I would look at is, well, what if I cut these in half? What do I get? Divide by 2, I end up with 600 divided by 8. And again, that's probably not such an easy problem, right? But what if I cut them in half again? 300 divided by 4. Can you maybe do that? Maybe not. What if I cut them in half again? 150 divided by 2. If I cut 150 in half? What is it? 75. Okay. In other words, you can manipulate problems, okay, rather than doing it out kind of the long way. And this again is helpful for mental math when you don't have a calculator or your cell phone happens to be broken and the battery's dead or whatever. You know, you can go and change problems into simpler problems and be able to do them more in your head than not. Here's another example. What if I had 7½ divided by 2½? 7 1/2 divided by 2½. Anybody? The answer to that right off the bat here. Jaden says no. Well, what could I do to those to make it easier to do? Elijah? No, not cut them in half, because what's half of 7½ is not going to be very easy to do. This time, what if you double them? What if you multiply them by, if you have 7½ and another 7½ you get 15, correct? 2½ and 2½ is, can you do that problem? It's the same answer as this would be. Okay, so the gist is, you know, you can change numbers. As long as you do it to both of them, you're not going to change whatever your answer is. Here's another one. 700 divided by 14. Probably can't do that in your head, but if you divide them both by 2 and get 350 divided by 7, you might have a shot at that one in your head. 350 divided by 7 is, Jaden? 50. Okay. So that's kind of the gist. They're gonna give you instructions and they will tell you what to do to the thing so that you don't have to do it. Now take out another blank piece of paper because we got one more thing to do. Now this one puts I guess equations. Although I think you're kind of used to this. Let me write down one. If you see a problem like this, b minus 5 equals 3.2. I guess the difference is now they're going to be shooting some decimals and fractions at you. When you see a problem like this, what are you supposed to do? Yeah? Yeah, think of a simple problem and see what process you do. In other words, it's a subtraction problem. So if I do 8 minus 5 equals 3, if I didn't know that this was 8, what do I do with 5 and 3 to get 8? Add them. So that's what you're going to do to this. You're going to add 5 plus 3.2, and your answer is going to be 8.2. Okay. Even if it's with fractions, what if you have this problem? R plus 1/5 equals 4/5. R plus 1/5 equals 4/5. Again, think of a simple problem. 5 plus 2 equals 7. You didn't know what this first number is. What do you do with 7 and 2 to get 5? Subtract. So you're going to take 4/5, subtract 1/5, and your answer is going to be 3/5. And one final one here, because time is dwindling here. What about this? What are they telling us to do there? That's probably about it. 3/5 n equals 1. Anybody? Here they're just trying to trick you with problems that you've already seen before. They just didn't write it the same way, which is what, Isabel?
It's 5/3.
Why is it 5/3?
Because the reciprocal of a fraction.
Exactly. They just, instead of putting the time sign like they usually do, instead of doing 3/5 times what number gives you 1, they took away the time sign and put a letter there. And anytime you see 3/5 times, or whatever, you know it is its reciprocal. Because 3 times 5 is 15, and 5 times 3 is 15.